Welcome to my channel. I originally intended to draw the circuit diagram for an automatic door, but I got stuck on a few components. Here, I'll introduce two types of LCD display solutions. The first one is the basic type. This is an earlier configuration where the LCD has a 16-pin pinout. Among them, 10 pins are related to data transmission, but in practice, this can be reduced to as few as 6 pins. For programming, I referred to the liquid crystal library. In this example, 4 pins are used for communication. The connection method is LCD GND connect to Arduino GND. LCD VCC connect to Arduino 5V. Rs, E, DB4 to 7 connect to Arduino D pins. After completing the wiring, I wrote the Arduino program in C++. The current tech trend is moving toward no-code, which is more user-friendly for people who don't know how to program. In Tinker's programming interface, the default is block mode. Personally, I enjoy coding, so I immediately switched to text mode. After referring to other project codes and libraries, I wrote the following flow. After startup, the LCD is initialized. Based on my current Arduino D-pin connections, I used D3, D4, D5, D6, D10, and D12. It displays 2 lines of text, waits for 5 seconds, and then does nothing else. In the test results, the LCD didn't display anything. I recalled from a previous experiment that the screen brightness might need to be adjusted. So I added a potentiometer and connected the signal to the LCD's VD pin. Tested again, still no display. Next, I referred to the constructor in the library and used the version with the fewest parameters, which specifies the 4 data pins for the LCD. Previously, I had intentionally changed them to different pins to see if it would still work. At that time, nothing showed up, so I reverted to the original pin configuration used in the constructor. Tested again, still no display. So what was the problem? The code compiled without any issues. Then I finally discovered I had swapped Rs and E in the wiring. After correcting that, the screen finally displayed properly. I still wanted to test whether changing the LCD's data pins would work. After switching to pins different from those listed in the constructor as expected, it didn't work. The LCD's pins must match the definitions in the constructor. After successfully getting the display to work, I tried writing code to have the LCD display song lyrics line by line. Each line stayed on the screen for a different amount of time. The result looked pretty good. Next, I tested the second type of LCD, the I2C model. The library used is liquid crystal _I2C. It only has 4 pins, which greatly reduces the installation complexity. Besides VCC and GND, it uses the analog pins A4 and A5. I had previously referred to existing projects compared to the previous LCD type. The difference is mainly in the configuration. In terms of usage, it's almost exactly the same. This experiment also ended in failure. I couldn't figure out what went wrong, so I turned off the simulator and looked to see if there were any LCD examples. Luckily, I found someone who activated the LCD I2C using block mode. Following the method introduced in the tutorial, I created the block and successfully tested it. I then discovered that it uses Adafruit_liquid crystal. So, I replaced the previously used liquid crystal _I2C with Adafruit_liquid crystal, and it finally displayed successfully. I've encountered cases before where switching to the LCD I2C version in block mode would also result in no display. My simple guess is that the simulator supports the relevant library during compilation, but the display functionality hasn't been fully developed yet. I've listed my Tinker project in the description. That's it for the simulation example. See you in the next video.